Today, I'm going to try to add as many easy to write features as I can into my shader. My to-do list only includes one idea for this, but I have a few more I'd like to try. The idea is if they're as easy and lightweight as I expect them to be, then I'll leave them in, but if they start looking tricky, I'll just cut them and move on. The reason I'm doing this pass is that I want to be able to rely on this layer for a little while now without having to visit it to add in these small, easy features that might actually help a lot. If I have to do this later, my memory is going to be more faded than it is right now. So if a feature is easy and small and I can get it in now, it's going to make my life a little bit easier. And it's going to make the things I can build a little bit higher quality if I can start using those features right away, rather than putting them off for a couple weeks and then going and hacking it in and, bouncing back and forth too much. I want to just do a nice final feature polish pass. So first, I'm going to deal with the one that's already on the to-do list, which is separately enabling roundness on each corner. This effect is very nice for UIs. It lets you make rows of buttons that sort of fit together cleanly, and then still also have those rounded corners at the ends of the rows or on the corners of the boxes and things like that. It also works great for widgets like tabs, where you want roundness on the tops or the bottoms, but not on the side that faces the panel or whatever. I learned how useful this effect is from seeing how Ryan Fleury uses it in his UIs. To implement this feature, I have to tweak my sign distance function a little bit. I've been testing the fragment's location against the rectangle's coordinates with absolute coordinates this whole time. What I mean by that is I know where on the screen the fragment is and where the rectangle is, and I calculate the sign distance from those coordinates. But to treat each corner separately, I want to start thinking of the center of the rectangle as the 0 point, because then I can think of each corner as residing in a different quadrant, and all I have to do to apply a different radius to each corner is to figure out which quadrant the fragment's coordinates are in. So the first thing I do here is shift my fragment shader from working on absolute coordinates to relative coordinates, where the coordinates are relative to the center of the rectangle. Now, I could send down a separate radius for every corner, but that would mean adding 3 new floats for each quad that I send down. And I really only care about this effect in one specific case, which is where I want to have 2 rectangles cleanly next to each other, and then one of them has rounded in some spots where it's not abutting another rectangle. So in other words, I really only care about the case where some of the corners are completely sharp and the others are rounded. So I think for that reason, a set of bit flags can work for this. I can put assign a bit in the field to each corner or each quadrant, and then use those bits to determine which corners just use a 0 radius and ignore the past radius. And here are the results from putting all those ideas together. This looks pretty good to me, so let's move on to the next feature. I want to be able to set a clipping rectangle for anything that I render. For instance, if I have a text box with a string in it, I don't want the text to run past the end of the text box and stick off the end. Manually enforcing this constraint by modifying the quad and the UV coordinates of the text inside the text box is technically possible in simple cases, but it's really hard work. And if we start throwing in fancy features like corner rounding and outline thickness, it becomes actually impossible to achieve the effect precisely, and so modifying the vertices isn't good enough. Now, OpenGL has a feature for this called the scissor rectangle, and I could apply that feature, but I can't apply it on a per quad granularity. If I started using that, it would require that separate batches of quads have their own set clip rectangles. So in other words, I couldn't take 2 quads with different clip rectangles and render them in the same batch. Since writing this feature into my shader lets me batch all of my quads together with mixed clip rectangles. It does cost me 4 floats per rectangle right now, but I think I can actually get that down to at least 64 bits, maybe even smaller, if I look at this again during the optimization pass. Finally, I want to implement rotation. This feature is a little bit more involved, so it's the one that might get cut if I can't pull it off. But I think I have a pretty good shot at making it work. First of all, one nice thing is I've already switched to relative coordinates with the rectangle at the center, and that's going to make things easier because now I can just rotate the relative coordinates of the fragment in the opposite direction of how I want to rotate the shape, and the combined effect of rotating the sampling fragment coordinates opposite to the way I want to rotate the shape is that I essentially get the shape to rotate the way I want. That's not the only thing I have to do with. I do have to change some other stuff here too. I need to make sure the points I use for the primitive geometry contain the entire shape. And there's a couple ways I could do that. I could just expand it by a certain amount. For instance, I could say anytime the theta is non-zero, the rotation angle is non-zero, just double the width and the height of the primitive around the center, and that's more than enough. But if I do something like that, I'm also going to be increasing the number of fragments that I'm overdrawing by calculating this costly distance calculation just to put nothing there. The alternative is to precisely place these by rotating the primitive geometry on the CPU first. That's not free either, but I think it's the right move for now. There might be even more clever things I could do, like applying the primitive rotation on the vertex shader side, and I'm going to explore that when I do the optimization pass. I think this feature will have a couple of uses, but the one I'm probably most interested in is the ability to create line segments freeform. So what I can do is take a rounded rectangle, and if I make it long and skinny enough, it starts to look like a line segment. And then if I can rotate it freely around its center, what that really means is I can place a line segment freely. If you give me 2 points, I can create a rectangle at the midpoint rotated such that it connects those 2 endpoints you gave me. And so that's effectively a way to build line segments out of this same shader that I'm doing everything else with. And with that, I can build a lot more stuff because a line segment is a very useful effect to have in this toolkit. Alright, this is all looking pretty good to me. That's it for new features for now. Next time, I'm going to take a look at all this new design and port it back into the original codebase renderer, and then integrate it in with an API cleanup pass. See you then.